Hello again and welcome to our video for DMA 20 section 3. In this video we're going to talk about dividing fractions. This is going to be a short video. There's not a lot to cover this time because we went over most of the important information in the last video for multiplying fractions. In this video we'll learn about the definition of a reciprocal, we'll talk about the rules for dividing fractions, and then work on an application problem. So on to reciprocals. Two numbers are called reciprocals if their product is 1. That means if you multiply them together, you get 1 back. And that's a fancy way of saying a flipped version of that fraction. So really, if you take a whole number and you flip it, or you take a fraction and you flip it, you'll have its reciprocal. So in these examples, we're going to find the reciprocal for each of these. The first is 2/3. The reciprocal of that is going to be 3/2. Why is that? Because if we're going to multiply these two numbers together, we would get 6 over 6 when we multiply across the top and bottom, which is equal to 1. So these are indeed reciprocals. The reciprocal of -3/4 is going to be -4/3. Okay, when we multiply a negative times a negative, that will give us a positive, so we need to make sure that reciprocal of that negative number is also a negative number, and then we get 12/12, or a +1. And last, we have the whole number 5. 5 we can represent as a fraction by writing over 1. So we would, if we were to flip this and find the reciprocal, we would say the reciprocal of 5 is 1/5. Now on to dividing fractions. To divide two fractions, we need to multiply the first fraction by the reciprocal of the second fraction, and then simplify the result if possible. Now, I use a little memory trick to help me remember how to divide fractions, and I call it keep, change, flip. Keep, change, flip. And that means we keep the first fraction, we change the division sign to multiplication, and we flip or find the reciprocal of the second fraction. So keep, change, flip is how we'll remember as we do these problems. So let's look at these examples. Forgive my typos. I wrote times in these problems when I meant to write divide, so I drew in little division signs there. But our first example is 1/3 divided by 4/5. So we're going to keep the first fraction, 1/3, change from division to multiplication, and then flip the second to get 5/4. And now we have a multiplication problem. When I multiply across the top, I get 5. When I multiply across the bottom, I get 12. And now I'm finished. There's no need to do any simplifying, so 5/12 will be my answer. Next, -9/16 divided by 3/20. I'm going to keep the first, -9/16, change to multiplication, and then flip the second, so I get 20/3. Now, I could start multiplying now, but I'm going to use that trick that we learned from the previous video when we were multiplying fractions. And I'm going to cancel out common factors in this step before I multiply. I see that 9 and 3 have a common factor of 3, so I'm going to divide both by 3. 9 will become 3, and 3 will become 1. And 16 and 20 are both divisible by 2, but also 4, so I'm going to divide by the bigger number. I'm going to divide 16 by 4 and get 4, and then divide 20 by 4 and get 5. Okay? So now I've canceled any common factors between the top and the bottom, and this will prevent me from getting really large numbers when I multiply and then having to simplify them. So remember, I've got a negative times a positive. The sign of my answer is going to be a negative. When I multiply across the top, 3 times 5 will give me 15. Then 4 times 1 will give me 4. So I get -15/4. And for now, we're going to leave this as an improper fraction. Last example, 120 divided by 10/7. Now, when I have a fraction, I want to write all numbers as fractions. So I'll write 120 over 1 to imagine that as a fraction. Keep the first. Change to multiplication. And flip the second, so I'll get 7 over 10. Alright, I could multiply now, but again, I'm going to divide out common factors early. 120 and 10 are both divisible by 10, so I'll divide them both by 10. This will become 12, and this will become 1. Alright, now I can multiply. 12 times 7 on the top is going to give me 84. 1 times 1 will give me 1, so I get 84 over 1, and I'm just going to express this as the whole number 84. Last up, we have an application problem. A stack of 90 3x5 note cards measures 3/4 of an inch tall. How thick is one card? Okay, so we've got, imagine here a stack of note cards. This is my crude drawing of a stack. And that distance, that height, is going to be 3/4 of an inch. We have 90 of these. 90 cards all stacked up. We need to find out how thick is one card. Well, the dimensions of the card, the 3x5, they don't mean anything. That doesn't help me with this problem, so I'm just going to cross it out. So the numbers that I'm concerned with here are 3/4 and 90. To find the height of one card, I'm going to take the total and divide it by the number of parts, and that will give me the size of the part. So the total here is going to be that total height, 3/4. And I divide that by my number of parts, which is 90, but I'm going to write that as 90 over 1. Okay. Now keep, change, flip. We're going to get 3/4 change to times 1 over 90. At this point, I'm going to cancel out common factors if there are any. There are. 3 and 90 are both divisible by 3. 90 divided by 3 is going to be 30. And now I can multiply. On the top, I'm going to get 1. On the bottom, 4 times 30 is going to be 120. So each note card is 1/120th of an inch thick. So there we have it. That's section 3. We talked about reciprocals, dividing fractions, and an application problem. Up in our next video, we'll talk about adding and subtracting fractions in section 4 of DMA 20.